Hi guys, and welcome back to the R tutorial. Now, often we find that you're faced with some data that looks like this. So this is income data, and you want to understand what are the outliers in this data. You want to identify, are there outliers in this data? Now, an outlier can be defined as an extreme value or something that is not comparable with the rest of the data. Now, outliers detection is very important because these outliers sometimes they skew our vital statistics. This could be the averages. For example, the mean is highly affected by outliers. So you want to detect them and be able to identify what do I do with it? Do I treat it as a null value? Do I remove it? Or sometimes it's also a key part of the analysis. You want to identify it because you're looking for outliers. For example, when you're doing fraud detection, the outliers are the key value that you're looking for. So you want to be able to identify these outliers and flag them in a way. So this data contains income that ranges from 1,000 all the way to 400,000. So it has not been arranged from the lowest to the highest. And I feel that we can use Excel to kind of understand how would you detect outliers and what is the kind of logic that goes behind understanding or detecting these outliers. Then you'll be able to use your programming languages like R and Python and be able to automatically detect these outliers, but you'd also have that logic and be able to understand how this is normally implemented. So with this data, I've created this sheet called Outliers, and I want us to use two methods. So we want to use the Z-score method, and we want to use the outlier or the IQR method that is normally used by the box plots. So using the Z methodology or the Z-score, basically all you want to be able to understand is this data, if it's normally distributed, 60% of the 67% of the data is within one standard deviation away from the mean. Then 95% is within two standard deviations. So if you are to decide and say, okay, I want to get 5% of the data that is beyond 5% of my data, then you can use two standard deviations. So the heuristic or the rule of thumb is two standard deviations away from the mean, that's an outlier, or three standard deviation. If you don't want to get some figures that you're not sure whether they're outliers or not, you can go for three standard deviations. So the first thing is you want to be able to get the mean, get the mean. So you get the average in Excel. So you use this function called average and you highlight the data you need. So this is supposed to be the median. So let's just go here, and this is going to be now the median. So you get the median. So the median is the mid-row point of the data when you arrange them from the lowest to the highest. So we have the median, we have the mean. We can look at the standard deviation, and we look at this. There is a formula in Excel for that. So we extract the standard deviation. And here we want to look at two standard deviations. So let's assume that our threshold is two standard deviations from the mean. So we multiply what is two standard deviations. So this is just two, and then we multiply by this standard deviation. And you have an income of 218 is and 18,000 is two standard deviations away from the average. And the average here is this mean, 67.667. And what we want to do is to be able to calculate now the upper bound based on the Z-score. So the upper bound would be, so this one is equals to um, two standard deviations from the mean. That's what we are saying. So it should be the average plus two standard deviations, like so. Then the lower bound should be the average, so equals to the average plus two standard deviations, or no, not plus, less, so that we get the lower bound. So here we have the lower bound and you have the upper bound. And here we can write a function that checks, is this data contained within the lower and the upper bound? And how you do that is you write equals if, and we want to use and. So what we are saying, I'll be able to explain what we are saying. So we want to check this figure and check, is it greater than our lower bound? And we also want to check the same figure, is it less than our upper bound? So meaning that it will be contained within the lower and the upper bound. And if it's within that threshold, we want to call it normal. Else, we want to call it an outlier. So that's the logic we want to impose. But now we want to fix this cell because this one is not changing. What is changing is this income, and we also want to change this. These are fixed points within our Excel. So it's saying that this one is normal. That's the calculation that has been made in Excel. And you see, we only have one outlier, which is 400,000. And the second method is using the IQR method. IQR stands for interquartile range, and it's what is contained within this blue point. So this one, the top part here would be the upper bound, the bottom part would be the lower bound, and then anything that is not contained within the upper and the lower bound is considered an outlier, and that's what we are trying to detect. And here, what you use is the first quartile and the third quartile. So this part is what is called the third quartile, is when you arrange the data from the lowest to the highest at the quarter part, that is the 25th percentile. That's where you get the first quartile, and then at the 75th percent is where you get the third quartile. And any data that is contained within that is called the interquartile range. That's what we want to detect, and then we're going to use the interquartile range to be able to approximate what is an outlier and what is not. And here, this is what I've done here. Let me remove this formula first. For the first quartile, I've written a formula which is equals to quartile, and then I'm giving the data array, and then I'm putting one there to show that it's the first quartile. Naturally, for the third, it's the same thing, but now 3 for the quartile, for the third quartile. For the interquartile range, you just get the third quartile less the first quartile, which is 45,000. Now, here what we want to do is to be able to calculate the upper bound. So the upper bound is the 75th percentile times now this IQR multiplied by a threshold. So what that is we want to be able to approximate this part now from the 75th percentile. So what we are saying is that the upper bound is the third quartile. So we pick this one, and then we say plus. We want to use a threshold which is 1.5. This is what is normally used by statisticians. So we are going to use it. We multiply by the interquartile range, and we get the upper bound. For the lower bound, we pick the first quartile, which is 17,500. I didn't put a formula, so we pick this one, and then we add 1.5 again times the IQR. It's not plus, sorry, it should be minus because now we are moving towards the bottom part. Yes, that's okay. So this 51,000 would be somewhere in the negative scale. So any data that is contained within minus 51 and 131,000, that one is going to be considered normal. Anything past that is an outlier. And here we put the same formula we had put. So you say if, and we put and, because we want it to be this logic or and these are the logic. And what we are saying is we want this data to be greater than the lower bound, and we also want the same data to be less than the upper bound. If that is so, we are going to call that normal. Otherwise, we are going to call it outlier. And it's that data point is considered normal, and we can say Control D. The reason this is so is because I did not fix some of this. This is a fixed point, so you put a dollar sign, and this is a fixed point. And why we need to do this is because we don't want it to drag this to move on to these other points. We want it to stick to this point, and we are fixing this. These are upper bound for all the data, and these are lower bound for all the data. That's why we need to fix it. And now we can drag this data again. And now we get that the two methods are showing us that the 400,000 is the outlier, and that's what we wanted. So when you now come to the programming languages like Python, like R, once you see a data point is considered as an outlier, you'll be able to understand what method is being used. Between the two methods, you can use any. If you suspect the data is normally distributed, you can just go ahead and use the normal distribution or the Z score. Otherwise, just use the IQR is normally good enough, and you can also draw box plot, and the box plot will be able to isolate the data that is outliers, and then you can be able to use the AQR method to be able to detect this and deal with it. So in later videos, we'll be able to go through how what you can do with the outliers and how you can now detect them using R